All right, imaginary and complex numbers. Where this comes out of, as we discussed before, if you had something like the square root of 9, well, that has two possible answers. It can be 3 or it can be negative 3 because 3 times 3 is 9 and negative 3 times negative 3 is also positive 9. So we run into a problem here is where they want to find a square root of a negative number. There is no real number square root. So they come up with what they call an imaginary number, which is represented by this, what looks like a bold italicized lowercase I. So we'll discuss this, and when you see complex numbers, it's no big deal. It typically is two terms where you have one real number and one imaginary. And that'll make more sense as we talk about it. Again, the square root of 25 can be either 5 or negative 5 for just the reasons we talked about. But what's the square root of negative 25? There is no number you can multiply by itself to get a negative number, because negative 5 times negative 5 is positive 25. So there's no real square root of 25. So they came up with a concept of an imaginary number. In the most basic form, the square root of negative 1, because there is no real square root, they simply call it I. And if you have the square root of negative 25, well, we could break that into the square root of 25 times the square root of negative 1, because 25 times negative 1 is negative 25. And the square root of 25 is 5. And the square root of negative 1 is the same as I. For convenience, they've created this. So we can just say 5I is the square root of negative 25. If you have the square root of negative 45, well, instead of writing out this step every time and writing the square root of 45 times square root of negative 1, we can simply write the square root of 45I. And again, we have to do the simplifying that we learned in the past. 45 can be broken into square root of 9 times square root of 5. Square root of 9 is 3 times square root of 5 times I. And for good form, they want you to put the integer, then the I symbol, and then the root last. So 3I square root of 5 is your final simplified form. Okay, a couple down here to try. If you have the square root of 49, at this point, you could say, well, I'll write it out one more time, writing the square root of 49 times the square root of negative 1. After this, I will simply skip that step. The square root of 49 is 7, and the square root of negative 1 is the same as I. So you could just jump right to that step and not write out this step here. So 7I is the square root of negative 49. Well, this would be the same as the square root of 75I, but we have to simplify that into the square root of 25 times the square root of 3 times I. So we have 5 times the square root of 3 times I. And again, the preferred order is we'd like to put it down as 5, then your I, then your square root of 3. Okay, looking at some more properties of imaginary numbers. Okay, we talked about I, which would be the square root of negative 1. And there's a pattern that happens here. I, of course, equal to I squared, which would be the square root of -1 times the square root of -1 is -1. I to the third is -I to the fourth is 1. And this pattern repeats itself. When you go I to the fifth, sixth, seventh, and eighth, it again follows this same pattern. I, -1, -I, and 1. And if you went I to the ninth, 10th, 11th, and 12th, it again would follow that pattern I, -1, -I, and 1. So following that pattern, if you wanted to find what I to the 23rd power is, the technique I use is, because it goes in cycles of 4, simply divide the power by 4. And whatever this remainder is here, 3, go over here and count down to the third in the pattern. So it goes I, -1, -I. So this would be what I to the 23rd is equal to, -I. First and foremost, always remember that I squared is equal to -1. You'll have to utilize this over and over again. And there's a note here to always remember, I is not a variable like other letters like X and Y and C and anything that we generally use as a variable. It's not the same concept. Now let's look at some operations that involve imaginaries. If we multiply 7i and 2i, just multiply the numbers first. So you'd have 14i squared. And as we said above, I squared is equal to -1. So that's simply equal to -14. Another example with multiplying, again, multiply the numbers, -6, and that would be I squared. And I squared, again, is -1. So you would just have 6. Well, these down here, we could break these each into the square root of 5, I, the square root of 20, I, multiply the square roots, which would give you the square root of 100, I squared. And the square root of 100 is 10, and I squared is -1, so you would simply get -10. Okay, solving by square roots with an imaginary number. Here, if you want to solve for x squared, like before, you got to get x squared isolated by itself. So we have x squared equals -13. Now when you take the square root, again, square root of a square cancels, and you have x equals, and it will be plus or minus, and it would be the square root of 13i, but for form they usually put the I before the root, the square root of 13. So it's pretty much what we learned about solving by square roots before, except you have to pull an I out to eliminate the negative underneath. Another example, again, we're going to get c squared by itself. So we subtract 36. And when you take the square root of each side, you have c equals the square root of -25, which is equal to square root of 25 is 5. And for form, they like you to write the I after the number. In general, they like you to write the integer, then the I, then the radical. Okay, complex numbers. This is simply when you have two terms, generally the ones we'll be dealing with, one real term and one imaginary. 5 is a real number, 2i is an imaginary number. In this example, 13 is a real number, and the negative 6i is imaginary. So complex numbers is just where you have the two terms, one real, one imaginary. So let's try a few operations here. If you had to combine these, which is all it is combining common terms, combine your real numbers with your real numbers and your imaginaries with your imaginaries. So 4 plus 5 is 9, and 3i minus 6i would be minus 3i. Over here, 6 minus 13 would be negative 7. Negative 12i minus negative 3i would be negative 12i plus 3i, so that would be negative 7 minus 9i. Now the next example is a little more complicated because there isn't any plus or minus. This is actually FOIL over here in example 3. So multiply 4 times 5 is 20. Outside minus 12i. Inside plus 10i. And the last, you'd have minus 6i squared. Well, here's a couple of common terms here that we'll be able to combine, and also realize that minus 6i squared is the same as minus 6 times negative 1, which would be the same as plus 6. So we'd have the 20 combining with the 6, giving us 26, and the negative 12i plus 10i, giving us minus 2i. Now, just like before, we're not able to leave a radical in the denominator. We're not allowed to leave an I term in the denominator, an imaginary. And the first one's pretty simple to eliminate that. We'll simply multiply the top and bottom times I, because you know that I times I squared is equal to negative 1. So on the bottom we have 2i squared, which is 2 times negative 1, which is negative 2. And on top, we do have to distribute this. So we would have 9i plus 3i squared. And as you know, 3i squared is the same as 3 times negative 1. And typically in their final form, they like you to write the real number first, just for better form. So you have negative 3 plus 9i over negative 2. In the second example, again, just like as if this was 1 plus a square root, we have to multiply by what we call the conjugate. You write it identical to the way it is, but if it's a plus, make it a minus. Had this been a minus, we would have made it a plus. And we'll see how this eliminates the I term. So we'll multiply this times 1 minus 2i. And we have to also multiply the top by the same. So foiling the bottom, 1 times 1, 1 outside, minus 2i inside, plus 2i. And the last term would be minus 4i squared. The reason we did this is these two terms will cancel. And as you know by now, I squared is -1, so that would be minus or -4 times -1, which would actually give us 1 plus 4. So we'd end up with 5 on the bottom up here. And we also have to FOIL the top. Five times 1, we'd have 5. Outside, minus 10i. Inside, plus I. And minus 2i squared. And again, we have common terms here. And you know I squared is -1, so this becomes 5 minus 2 times -1, or 5 plus 2. So we have 7 plus 9i. Again, just like the concept of not having a radical on the bottom, you're not allowed to have an I term on the bottom.